Guys, welcome back to Code with Dave Shook, and in today's video I am going to demonstrate how I use Stellar Classification Dataset to build two machine learning models, which is our Logistic Regression and Decision Tree model. I am going to go over how I prepared the data, train the model, and then compare the results to see which model performed better than the other. It is declare my libraries. I've used the Panda library for loading and working with the dataset, the MATLAB library for visualization, and then the other tools are for future scaling, selections, data scaling, and then also training the model and also model evaluations. So what I did first was I loaded my data set and then read from my data set. So I'm reading right here. I'm reading from the data set, and then after that what I will do is like this, I'm gonna print this out to check for missing values and any errors that might be in the data. And yeah, so I'm going to run this real quick to see if we see any errors or missing values. Okay, so the data says, it's already running. And as we can see here, we don't have any missing errors, or we don't have any errors or missing values, so we're good on that part. It looks like I've run it multiple times, so I'm going to delete that. So after loading and reading from the data set, I then checked for, after this, I then, applied two features engineering techniques by creating new columns from existing data. The first column we have the UG, which was created by subtracting the U values from G values, and then the second filter was created by subtracting the G values from the all values. And then these new features are to provide additional information that might help the model identify patterns or improve classifications accuracy. So yeah, so that's why we have these new features. Okay, so then after that I created the future selection, and then so the future selection looks at all the future columns using this right here, and this. So it's gonna use that to look at all the future columns, and then figuring out which one is most useful for predicting the target. So basically the class, and then keeps like the top 10. So yeah. So what I'm gonna do now is I'm going to put this back, and then I'm gonna run it again. Let me do that again. I'm going to run it, and then you're gonna see the results. So these are the results, as we can see. Okay. So now what I did, this one, we are splitting the data into training and testing. So let me uncomment that real quick. Okay, so So we have about like 20% that's going to 20% that's going to the 20% to test how well the model will perform, and then about 80% of the data is going to train. So it's going to go into the training model. The model is going to train on about 20%, and it's going to 80%, and then it's going to train and on about like it's going to train on 20% data. And then after that I'm using standard scaler to scale the data. This helps, which is this. I'm going to comment this out as well. Not coming out. I'm going to put it back. So what this does is it helps all the features on how, like, it helps to keep all the features on like a similar scale, so the model can learn from them like efficiently, so the model can learn pretty well. So the model is able to learn pretty well when it's able to learn pretty well when the scales are like when the data is on the same scale. So yeah, that's what we're doing there. And then now we're going to train this logistic regression model. Okay, let me comment that out real quick. Not coming out, I'll put it back. Okay, so now we're training the logistic regression model using the trained data. And then during training, the model learns the patterns from features and their correct classification. And then the set max is 1,000, and which is like it gives the model enough time to find the best solution if needed. So the model is gonna go over like 10,000 times training the model. So yeah, and then after that we're going to run. I'm gonna run the code. Okay, let's run the code to see how the model performed. Okay, so as we can see here, after evaluating the logistic model, it looks like the model achieved accuracy. Accuracy is like about, it's 95%, and then the precision and then recall and 1F score are also high across the three classes, which indicates the model is like performing like well when classifying stars, galaxy, and classifying the data. So yeah, so that's pretty good. Okay, and then now what we're gonna do, what we have here, I'm gonna comment this out again. Okay, so now we've created the confusion matrix for the model. What the confusion matrix does is that it shows how many objects are like classified correctly and like where the model like made mistakes. So what I'm gonna do is I have already ran it, so we can come here and look at it. And yeah, this is the type of like how many objects are classified correctly and when the model made mistakes. So yeah, and then now we're gonna go back here, and now we're gonna train the decision tree model. I'm gonna comment this out. So the decision tree model is like the decision tree model predicts by asking a series of questions about the data. So it's, I'll like say like it's kind of like a float. So what he does is like he asks, for example, it asks, oh, does this go here, yes or no? And then yeah. And then does this belong to this, yes or no? Then if it's yes, then yeah. So each answer leads to another until the model reaches the final prediction. So yeah, so that's what the tree is. And then I can run that too, so we can see the results. And this is the results of the this is the results of the, this is not, okay, so this is that tree. Let me go down. Oh yeah, these are the results of the tree. So the tree, the decision tree model is more like, it has more arrows than the logistic regressions, as you guys can see. So we have about, for the logistic regressions, we have about 70% accuracy, 75% accuracy, and then for the decision tree results, we have about 90% accuracy. So yeah, and then now this is basically just like a second confusion matrix for the decision tree model, which I kind of already have right here. I can run it again. So this is the first one. See. Yeah, this is it. Alright, so yeah, so now we're able to see like how well, which one does better, which one did better, and obviously the decision tree model did better on this data set based on the calculations and the results. So yeah, so basically that's all for this video. Thank you so much for watching, and you have a good one. Thank you.